We're probably talking about meals here which are 97% or greater water.
So these are like edible drinks, really?
They certainly have the functionality of a drink, but they would be something that you would eat with a spoon. We've worked with colleagues in Loughborough University in their sports science department who are world leaders in understanding how to very, very quickly hydrate elite athletes. Now, we're not necessarily going to do that with food, but they know a little bit about what happens in the stomach in terms of hydration. So we've tried to marry those two worlds together. And now we're looking at using food structures to hydrate not elite athletes, but the general public. There's been some work done, particularly in schools in the UK, about understanding whether children, if they're properly hydrated, perform better in the classroom. The acknowledgement is that they do. However, if you hydrate through water, that induces what's called a diuretic spike. That means that water hits the small bowel, and hormonal feedback means that you want to get rid of it and therefore go to the toilet. So one of the problems about having children optimally hydrated is that they're always disrupting the classroom to go to the toilet. One of the things that we've done is to use a technique that our colleagues in mathematics and physics have developed. In fact, Sir Peter Mansfield got the Nobel Prize for developing, and that's magnetic resonance imaging. And this essentially, what we're looking at here, is somebody's stomach. This is just after the meal has been consumed, and this bottom image is 1.5 hours later, and the food structure in the meal has been designed such that in the stomach environment it actually gels. So the structure in the water thickens and becomes jelly-like. And I think what we're seeing on the darker area on the outside of this image is a jelly bag full of water. And that jelly bag is then the structure that's releasing the water in a pulsed time sequence, which then keeps the body hydrated in a pulsed fashion for much longer. The potential here is that we can have a structure that could be eaten at the start of the day. That could be for you or I, the busy office worker, for the children at school, and also for, say, the elderly in care homes who don't have access to water readily. You could feed them in the morning and then their body is optimally hydrated throughout the day. There's also potential for this to be a product that's eaten at night time. One of the things that people tend not to do is to drink just before they go to bed because they know they're going to be disturbed during the night to go to the toilet. So if this product was taken just before bedtime, essentially the body would be kept hydrated during sleep time without any disturbance.
This is great. Where can I buy one? You
can't at the moment. So this has just been through proof of principle in a development agency funded project involving the University of Nottingham and Loughborough University. And we're currently looking for opportunities to take this technology further. We've looked at what's on the market in the sports nutrition world, and you can have energy jellies. Now, the products that we're talking about currently are not too dissimilar from those. The meal itself then would be taken with a drink, and the meal and the drink then interact with one another inside the body.
Why can't I just eat some bread or a biscuit or something before bed? Those things contain water, don't they? Most of my food contains water. Why can't I have a watermelon before going to bed? What are you doing that's so good?
One of the things that I think we're doing in this technology is locking that water into a gel structure. Now, watermelon you would chew, and the whole process of chewing is going to break open the cellular contents within that watermelon, which will release the water. That water then is no different to taking a glass of water, and therefore that water is unstructured. What we're doing in this technology is to lock up large amounts of water in a gel structure, and then that water is released. The moisture content in a piece of bread is much, much reduced. So for a volume per volume basis, we're providing here significantly more water than you would for just having a cookie or a piece of bread before bed.